Examples include SSL. What layers of the OSI model does this work at?
Would that be application?
Good guess. It's actually wraps from the application down to the transport. So 4 through 7. It's protection in the OSI model, layers 4 through 7. Some places you'll actually see it 5 through 7, but for you guys, 4 through 7. Then you've got Ipsec. That's layer 3. And then you've got, at the application, the next two you can put layer 7, so SMIME and HTTP are really layer 7, and then SET is its own thing. SET is called Secure Electronic Transaction, and it was developed by Microsoft and Visa to basically exchange credit card data. You remember we used to do that system? They used to swipe your card, and they mail that stuff in or did something with it, and you had, actually put it on your credit card like a week later. For us, that meant we could buy something and not pay for it for a week, is what that meant. But they wanted to replace that, so they came up with a digital way of doing that, and that's called Secure Electronic Transaction. And it's basically, how do I take money from my account to the account holder in the store that I'm buying something from. So SSL. SSL wraps around from 4 through 7, layers 4 through 7. It wraps the protocols inside of 4 through 7, anything in 4 through 7. It's wrapping all of that. So we got a nice list of HTTP through network news. Those are all layer 7 stuff right there, but it's wrapping the whole thing, layer 4 through layer 7. And notice that it has elements of key exchange, asymmetric, and symmetric.
So these applications create their own public and private keys?
No, the applications don't. SSL handles all of that. Remember, they designed all these protocols to be functional. They didn't design them to be secure. So they outsourced security from the actual protocols to SSL, and they use SSL to wrap everything.
SSL then creates public and private keys and sends the public keys downstream.
Right. The only thing I didn't like about that was the protocol piece of it. The protocols, they're just doing what they regularly do. It's SSL's the wrapper.
Does SSL actually generate the public and private keys, or are they
I think
generated by a
server.
key authority or a certificate authority, right?
Yeah, I mean, I've used on routers. I've had to generate RSA keys and things like that, so I had to do it.
Right.
And then you connect to that server and I had to do it.
DoD servers have a server certificate created from the DoD public key infrastructure that's installed on it.
Right. Yeah. The keys, the public and private keys, are actually generated through certificate.
Yeah, I'd have to pull the the command line help on that one.
Backing up a bit, you said that this has elements of, and then what did you mention? Was it? There were 3 things that you said.
I missed it.
I thought it was on that slide when you were talking about it.
This one? Oh yeah. Towards the bottom here, you got the digital certificate for that's the server side piece of it, and you have asymmetric and symmetric. So, but you got to get, because there's asymmetric, you still got a key exchange piece of it too.
For HTTPS in particular,
sure.
That's the one that the majority of the internet, when you're dealing with stuff that you want.
By convention, HTTPS calls and such forth.
Where do the public and secret keys come from when you're exchanging information? For example, with your bank sends you a public key, and they use a private key or a secret key. On
the web server, you have to import your private key to the server, and you have to tie it to the server and its IP address.
So who creates that private secret key?
The network administrator of that server.
Okay.
Or maybe that might be outsourced to a security guy who will provide it to the network admin that will just put it in place. Probably more likely to happen. Like for example, when I got the my certificate for the code learning, I had to submit basically a request, to register basically. Then GoDaddy created the certificate, and I worked with them to put it on the server, tied to my IP address and my domain name. So once it's on the server side, now anytime the client browser connects to that server with HTTPS, bam, that public key goes down. So anything that I send to the server, they can decrypt the private key on the server.
And then when I'm sending back something back to you, I encrypt it with a public key that you send me, and you decrypt it with your private or secret key.
Sort of.
Well, because it's a two-way secret channel, or encrypted channel.
It's all established based on the certificate, one certificate, which is the certificate on the server.
Right.
Right.
But all I need to do is do the asymmetric piece for the sake of setting up the session key, and now everything that we send between each other is
It's done with a symmetric key.
Yeah, but I just use asymmetric to protect the. I got to get to you first, so asymmetric first, and then we use that to create a session key. Then it's symmetric from that point out. The whole time we communicate back in the server. So then you only need the asymmetric to set up the relationship.
You mentioned you used desktop sharing or whatever the heck it's called on Windows to log
Remote desktop. Yeah.
remote desktop. So who establishes the secure link there? Are you using a VPN?
Well, I'm just going ad hoc computer to computer at that point, so there's no encryption on my remote desktop. I'm not RDPing into the server. I just do it to my home desktop.
Right. So you're not using encryption on that. Okay. Why? Just curious. That's a side problem.
There's nothing on it that I care to protect. For me,
But if you were, then you would be creating a VPN or some sort of encrypted
yeah, I want to
channel.
create a right.
Now, who creates? Where do you get? Are those just private keys shared on each end of?
It depends on which layer you want to do this at. Now we're talking VPN. Now we're talking layer 3 security.
So you would create a secret or a private key on your home computer and your work computer, and then you would have both ends of the private.
A little bit more to it than that. IPsec, the way IPsec works is like a truck. I use a truck example. So you got the header and then the data, and you can use Kerberos, digital certificates, or a pre-shared key to authenticate that traffic from the source, basically my computer, to the destination, the home computer or the server. But the network admin, in this case me, I'd have to set that up if I want all the traffic to go. But because there's a lot of networks that I don't control between me and the destination network, I can't add any protection on the front of the truck of the header. I can only protect the data that goes across. Just data security. Right. But if it was a point-to-point link, then I could add in an integrity check to the header, though. Well, this one. Any questions? Got that? All right. All right, so here we're going to go through the example, right? Web client establishes a secure SSL session with a web server. So step 1, client establishes a connection, says, hey, server, I want to talk to you on port 443, or what we would normally consider HTTPS. Client sends a list of, what I can use for symmetric encryption. So I say, here's what I can work with. The client receives a copy of the server certificate and the public key, certificate and public key. And then the server says, okay, well, thanks for telling me what you can work with. Here's what I'd like to use. I'd like to use the strongest encryption possible. Can we use that? So far, so good. So step 2, web client establishes a secure SSL session with the web server. Client selects a pre-mastered secret and sends it encrypted with the web server's public key. So think about it. The web server's public key is going to encrypt that. You're going to send it back over to the web server. The web server is going to decrypt it with the private key, and now you can get tied into a session key. Because we've agreed on the symmetric algorithm to both of us use. So there's a couple pieces of that. One, I got to choose the algorithm, and we got to choose a key to get into that algorithm. And I'm going to send that to you. First, I'm going to send you my options, and then I'm going to send you the actual key. It's a little bit more, back and forth than this. This makes it look like it's just in 2 steps, but the back and forth is probably already talked back and forth about 10 times already. All right. So now both parties have the same session key to secure data between them. And this will continue until you close your web browser, basically. And since we're talking about web, this is basically how HTTPS works. So it not only protects the authentication, but also the channel for as long as we have a relationship. or a session, better word. So you take session into secure session.
So, the statement you made, until you close your web browser, not until you go to
Close down the session,
Right.
which there's a difference between the two, right?
Right.
I could just hit the X on the browser. In that case, the server side is probably still waiting for me to end the session, which could be a bad scenario in the long run of things. Or I could say, it's time to log out, and then we'll actually tear down the session. But just clicking an X on the web browser, that leaves one of the parties waiting for the other.
Well,
Until a timeout happens.
With my bank, there's a timeout function.
And that's why you have.
Every bank has a timeout function.
Yeah.
So it's the same.
I think that's sort of
It just, the session
So
key is
what-
only gonna last so long. It's
So-
not.
Yeah, but one of the points I wanted to make was that if you're in a, if you got the session key set up, right, and you surf away from the bank site to another site, right, that session is still set up, and it's still waiting, right?
So like if you're in like a public like kiosk or something like that, somebody could come back and essentially hijack your session.
Yeah.
And the same thing with mail accounts. And those are problems of client-side software, because if you're using like Internet Explorer, and like say you're at the kiosk and you close down Internet Explorer, and I come up next and I open up, and Internet Explorer didn't finish like closing down, it's like hung or a race condition, similar to a race condition, and I open up Internet Explorer, I can connect right to your mailbox or whatever you connected to, because my client still has a session open with that
Right.
server. So the client-side software screws this up all the time. Caching and things like that. Also,
And sometimes webmail doesn't close down gracefully even if you close IE, and the session is open, and you can open up IE, another session of IE, and go right to your
Go right to your web
webmail.
browser, yeah.
It's still active.
Right, yeah, that's exactly what I'm referring to. Those
Yeah.
types of client problems,
Yeah.
that has nothing to do with SSL. That is a software piece that you use.
So those are vulnerabilities you should be aware of.
Yeah, well, that's why, we should teach people to log out and not just hit the X.
Yeah.
I just assume get away from the X altogether, file close. Or log out first. IPsec, right? So this is IPsec. So we're talking about, the road system and getting to and from each other, routing protocols. And we're going to add in security to IP. So this really works at layers 2 and 3 of the OSI model, because we have both tunneling protocols and encryption protocols. And it's transparent to the application. Why?
Because it's happening below the application,
Right,
and it's
yeah.
getting stripped away on the other side before it gets to the application.
Yeah, all the application stuff happens 5 through 7. So that's what HTTPS protects. That does protect the application. Where IPsec doesn't care about that at all. It's just data to IPsec. It's just cargo in the back of the semi-truck. That's all it is. So IPsec was designed to defend against, sniffing attacks. So you just plug in, you want to sniff traffic, you can't read it because it's encrypted. Or integrity checks too, because IPsec has integrity checks.
So would you say then that IPsec is IPsec is concerned with the encryption of data as it traverses the network,
Yes.
whereas the SSL is concerned with
Application to application.
encrypting the data as it. I mean, still traversing the network, but you want to.
Yeah, but two different components of security. One's doing it in transit. The other,
Only in transit.
yeah, well, IPsec would be only in transit.
Right.
And then the SSL piece of it,
Is doing it from the application.
it basically doesn't even know that there is a transit. It just thinks I'm connected to you. It doesn't know how I got there, because that's layer 3's job. It just thinks that I'm talking to you and say how far we were. The application doesn't care how far you are away. That's IPsec's job, or IP's job, the routing and routing protocol's job. So you get different layers, different levels of protection. Using them all would probably be a good idea, again. Because we can use digital certificates to tie into IPsec, it prevents identity spoofing because you can authenticate each host. In some cases, then out service. It's in theory designed to protect against man in the middle, but they got protocols that can do that now. You can actually insert yourself into IPsec conversations, or even HTTPS conversations. That'll blow your mind.
Yeah.
That's called SSL in the middle.
That doesn't sound good.
No, it's basically two tunnels, and the person in the middle can decrypt all the information. but you have to use a program called fakecert.exe to basically.
So you have to get in when they're setting up the session.
Right. Well, think about it like this. I often do this on the camera, right? You got the source and you got the destination. Well, normally they think they communicate directly with each other.
Right.
But if I insert myself in the middle, I could say to the client, I could say, I'm this guy, and create a tunnel here. And on this side, I could say, I'm the certificate of that guy, 2 fake certs.
Right.
And if you don't authenticate and non-repudiate those, now I'm in the middle.
Right. But you have to insert yourself
Yes.
at the beginning of the session.
Right.
You can't insert yourself in the middle of the session.
Why?
Because you already
gotta be
shared the
involved in the
secret
key
key, and
exchange.
so the key exchange has already occurred.
Right.
You have to do it when the key's being exchanged.
Right, I knew you knew the answer. That's why I asked. All right, so good. And if you can protect the data in theory, well, you can protect the applications too. All right, so there's basically 2 components of this. But now's a good time to talk about the truck. Yeah, thanks, sir.
Which one is it? Which one?
Top one. This feels like a bar of soap. All right, let's talk about the truck. Did I do the truck on the security foundations?
No.
I didn't.
I don't think we've seen the truck before.
Well, she's within a different class.
Oh.
I know what you're thinking. I know what you're thinking.
No.
You're thinking to yourself, I wish I could draw a truck that good.
Actually, yeah.
Actually, yeah.
Actually,
Except my truck's got spinners. When I'm at red lights, they keep going. So here's the truck. Since we got to talk about moving things around, I kind of came up with the naming analogy of this. So hey, how you doing? You probably want to write this down.
Do I have to draw that?
Probably a good idea. Because if you can walk yourself through this, what I'm about to show you, then hey, please do. This is designed for you to actually get it, and then you don't have to memorize it. So I just a 4-node network here. We'll get into that later. Some of the basics, though. Would you agree that this would be the header of the truck? All right, so we call that the authentication header, and this would be the payload. So that would be the encapsulation security payload. And you can do this on your notes because half the acronyms are already spelled out. And so I'm going to break down the pieces of security as they are in the truck. And basically, as you would drive through a road system, we're just going to convert that to traffic. These guys?
Yeah.
Just 4 routers. 4 routers down here. What are you looking for, Len?
It's chock full.
So okay. Let me help you. You got the front of the truck. That's called the authentication header. Then you have the back of the truck. That's called an ESP, encapsulating security payload. So just like a truck, well, what part of the truck is the payload? Back of the truck, right? Or their header would be the front, so that's the front of the truck. And then these would be A, B, let's do C, and D. Okay, 4 routers. So once you guys get this down, let me know because I want to kind of do this all together. Anybody do IPsec in here? You do a little bit of it?
Yeah, I've done some.
Okay, so you're gonna make sure I'm telling the truth here. Front of the truck, authentication header, back of the truck, encapsulating security payload.
my truck looks horrible.
I told you, jealousy will get you nowhere, man. Told you. And in 3 dimensions. I could have a 4th dimension for this too. That's not so bad for a 3rd grade.
Actually, that might be a dig on 3rd graders because
Smart as a 5th grader.
my son's a 3rd grader and he can draw a truck much better than that.
I was the smartest kid in 3rd grade. I was also 18. Got all the jokes, folks. No shortage of jokes.
Oh, that was a joke? I'm sorry.
Are we gonna get to go back
I'll let
over
you figure it out.
the good, bad, opportunities thing?
Yeah, we didn't do it after lunch.
good,
It's so
good.
hard to remember that one after lunch. It's easy to do at the end of the day for some reason. All right, so we want to get from A to D, and we're gonna think through this. All right, so let's. You can do your. I want to do some IAC triads too. So let's do an IAC triad for the front of the truck and an IAC triad for the back of the truck. And the first one I want to address is confidentiality.
I didn't leave room for my triads.
You can put them anywhere. I just want to address integrity and confidentiality in the front of the truck and the back of the truck. And we can do this in a physical world to prove that this stuff actually works. So, all right, so let's say that I want to go from point A to point D. Everybody with me? Say hi. All right. I'm going to go from point A to point D. If you were driving this truck and I tried to add a confidentiality, in other words, I tried to encrypt you, that means by keyword alone, you cannot disclose anything to anybody else who is not on the authorized list. Agree or disagree?
Agree.
So what happens when you want to go to D? What happens when you go through B? And B, this router here says, where are you going?
You said, oh, can't tell you.
Now you can't talk. So basically, that's the end of the path. You would never be forwarded past point B. Agree or disagree?
Agree.
Because you can't talk, you can't disclose it. So you cannot have confidentiality in the header portion of the truck.
True. Is there ways you can get around that?
Sort of. But you could add an integrity check, so let's prove it. If you are going from A to B, when you get to B, if you add an integrity check, when you go from A to B, you're going to say, B's going to say, hey, where are you going? But now you can tell it where you're going. So that checks out fine, because there's no restrictions now, because we did not encrypt. But then the next question that it's going to ask is, do you still have integrity? And if your destination is only B, nothing's been modified in transit, you have integrity. Agree or disagree?
Agree.
Agree.
But if you tried to go to D, when you got to D, you'd say, oh, hey, where are you going? Oh, this is the destination? That checks out. But now has anybody changed, modified, altered, deleted you in transit? Well, B actually did.
B changed your header yet?
B changes the header. So an integrity check would fail. So this tunnel can never extend other than a point-to-point link, or the integrity check is going to get violated. Follow me on that one?
Mm-hmm.
Sure. So it's got your wheels are turning. So
How you get an integrity in D is the next question.
you'd have to add a separate tunnel.
Right. The panel.
But the problem with that is that if you're in clear text for a split second here. So if I want to increment tunnels, I could do that, but that's what's happening. That's how you'd have to, if there's 5 other networks here, you got another network out here, and you don't have to write this piece of it down, I'm just giving you an example, right? No matter how many networks I go through, I would have to keep adding tunnels to increment that up. Agree?
Mm-hmm.
All right. So that's the only thing, this is the only thing that you can do is at one point or a direct link if you want to add integrity to the front of the truck. And you cannot do confidentiality, or you can't disclose anymore, even if it's your recipient, you can't disclose unless they already have the pre-shared key. So integrity, no, confidentiality, no, integrity checks out just fine. From point to point. From one point. And that's exactly what you get, and that's why we use the authentication header. We can use it for like a T1 line or a line that you can control. But once I go out here into internet land, let's pretend this is internet land. Once I go out on internet land and I don't control all of the links and the routes between the source and the destination, you can't use an authentication header because you can't set up the tunnels. Agree or disagree?
Agree.
Right. So really you can only use this in special circumstances.
Like if you have a dedicated line or something from you to like
You'd have to have a dedicated line and you'd have to control it. But you could, you could add up tunnels from A to D in this case, but you'd have to own the network and set that up in this fashion.
So what you've just said is there's no way on the internet to guarantee integrity.
On the header. Because there's too many routes, there's too many people that want to change. The only way to do that is if you did control every single hop
So you're
there.
going to do it in ESP, you're going to do that.
And that's exactly what we do. We basically say, let's get rid of the header. Let's not add integrity here, but let's just focus on the payload. Let's make sure we can get integrity and confidentiality on the payload.
Your slide says authentication header provides integrity of the data. That's not true in most cases.
Well, in this case, in the header, the data would be your
Point to point.
yeah, the true data is here, but you also have stuff in here too, but that would be your source address and destination
On your
address.
slide, you've broken out the AH provides the integrity and ESP provides confidentiality. That's not true, what you just said.
Well, write down what I'm saying now.
That doesn't correlate with what's on your slide.
On page 91,
There's
right?
another
Yeah,
part to this,
yeah,
isn't
page
there?
91, it doesn't correlate with what you just said.
Yeah, well, the data piece of it, basically, that's inaccurate because the it's not this piece that we've only talked about this, and the only data that's in here is source address and destination address.
So header
if you
data.
don't like the way that it's worded, we have to change that and word it in a way that's, in this case, the data they're referring to is the source and destination address.
The header.
Those are, the header data, or the fields within the header.
Okay.
So, sorry for the ambiguity there, but let's correct it as we go. All right, so that was the authentication header. Did you say there's something else in the ESP?
Well, it just says confidentiality, but it's not. You're going to.
Well, and that's kind of inaccurate too, because you actually can do, and I can prove it, you can add integrity. So add integrity to the ESP node. I just want you guys, I want to make sure we're all on the same sheet of music here. Alright, so in the payload now, if we leave the front of the truck alone and we go with the payload security,
What does that stand for again?
okay, encapsulating security payload. I'm gonna do it in green for you guys, DSP. Now you can go anywhere you want because nobody's going to mess with the header, or people can mess with the header all they want, but they got to leave the data alone. Like every time you go through a toll, they don't exactly tell you to open up the back of the truck and let me inspect it. They don't exactly do that all the time. So you want to keep whatever's in the back of the truck. Nobody can see what's in it. And not only can they not see it, but they also can't change it. You can add an integrity check and a confidentiality check. And you can go through as many routers as you want now because there's no restrictions on the header. Follow me so far? Okay. So some terminology here. Let's do terminology. This is called tunnel mode. And this is called transport.
How is that working there?
Or end-to-end. Yeah, I'm just going to write E to E, end-to-end. Those are the names of that, so I'll do it up here too. End to end.
So ESP is end-to-end, that's what you're saying
and
here?
this would be tunnel. Because they call them tunnel mode or transport mode or tunnel mode and end-to-end mode, and that's where that stuff comes from. It's basically the big picture of add a whole bunch of tunnels up, or hey, you can go end-to-end because there's no protection on the header. Or there's nothing that's going to get violated in the header because you didn't add any checks to it.
The tunnel mode is also point.
This is also point-to-point. You have to own the networks and control them because you got to set this up. But so if you want to VPN in from your home to your work, what mode do you use?
Transport.
You have to use transport mode. You have to leave the header alone. But if you want, you got a private link from hospital to hospital, you can use tunnels all day long.
And-
you control the links.
And I would assume that the advantage of a header or the what was the AH again?
Authentication header. Yeah.
The advantage of using that when you can is that there's less. It's faster. I mean,
It's not necessarily faster.
what is the advantage? Why would you?
Out here, you're worried about disclosure to in the internet. You're worried about disclosure to people you don't know. Inside your network, you're still worried about disclosure, but there's a small element of, well, you wouldn't have authorized them on your network anyway. You shouldn't allow people to plug in, but at least they should be internal users to the organization. So
YouTube it.
the advantage of the authentication header is you get to add an integrity check here. So there may be certain instances where you can, you have the architecture to support that. You can add more integrity checks if you want. I don't know if I answered your question.
I'll YouTube it.
Well, ask your question again. Why would you want to use AH?
I just said, why would you want to use one over the other?
Well, if you control your network, you can add an authentication header. If you don't control the network, now you're restricted to only the stuff in the ESP. And to kind of elaborate this a little bit more, your choices are AH plus ESP, so you could add it both the authentication header and the payload, but because you add protection here, you're still limited to this. Or you can just do the ESP. So really, when you say AH, that's really AH plus ESP in most cases.
This is not really established, this is not associated with establishing a VPN or things like that.
This would be encryption for a VPN.
Yeah, ESP would be.
Right.
But it doesn't have to be.
That's also correct. Because you can use other VPN technologies, not just IPsec. Because like Microsoft has point-to-point tunneling protocol with Microsoft point-to-point encryption, or you could use layer 2 forwarding or layer 2 tunneling protocol with IPsec. Right, or you could go open source and use something called SWAN, Secure Wide Area Networks. It's just an open source way of doing it. If you want. So you're not limited. You do have implementation flexibility. I'm just trying to break down the IPsec and walk you through the process of what hopefully makes sense and what doesn't make sense. Because if I just list out the protocols and say, hey, the AH does this and the ESP does that, you really don't get to apply the knowledge. I'm just throwing junk in your head. But now that we've kind of worked through this, you should have a better understanding of it because the scenarios and when it makes sense and when it doesn't make sense. Or I could have just listed them out, but I don't think that has any value to it. Especially on something like this. Like you actually get to walk out of here and go, oh, you know what, that made sense. Hopefully. Or what the hell did he say? One or the other. All right, so you're the IPsec pro. Would you agree with what's going on here?
The only thing that I would say is that that obviously AH plus you get your authentication header is only valid for tunnel mode, right? So right. So that's so I hope everybody's clear on that, right? So
and then you can optionally add in the ESP.
Right. Okay. So
You don't have to.
So the authentication header, the integrity